Hi everyone, welcome back to CHM421 Analytical Chemistry. We continue our learning for topic 5, Gravimetric Analysis. If you still remember on the previous video, I'm talking about two methods to calculate the amount of analyte in the precipitate form. So it can be calculated by using chemical factor or gravimetric factor. So in this video, we will learn these two methods. So chemical factors, the calculation of the weight of constituent or the weight of analyte in a given precipitate will follow directly from the proportion. So this is the formula to calculate the chemical factor. So you have to identify carefully what is the meaning for each alphabet in this chemical formula. All right. So is can see in this slide AABB is the these two is the molecular weight of precipitate. Uh, M is the molecular weight of analyte or the constituent that we want to determine. And small n is the molecular weight of analyte in molecular weight of precipitate. W is the weight or mass. We can call it mass also can, weight also can, mass of PPT, and X is the mass of analyte. So if we want to determine the percentage of analyte in the sample using chemical factor, so the mass of precipitate over mass of analyte over mass of precipitate times 100%, where W is the weight of sample or weight of participate uh, precipitate. Okay, sorry. All right. For the gravimetric factor, the weight of analyte, the mass of analyte per mass of precipitate multiplied by the mole of analyte uh, per mole of precipitate from each mole of analyte. So this is the chemical formula to determine the gravimetric factor. So if you can see the gravimetric factor is the molecular weight of analyte over molecular weight of precipitate multiplied mole of analyte in over mole of precipitate. Okay, so we will see the example how to use this chemical this formula later on. So the gravimetric factor is the mass of analyte over mass of precipitate, because because from the formula of mole, is a mass over molecular weight. So you know mass should be mole times molecular weight. So this molecular weight times mass, molecular weight times mole is a mass of analyte. Molecular weight of precipitate times mole of precipitate is mass of um, precipitate. This is why gravimetric method factor is the mass of analyte over mass of precipitate. Okay, if you want to know the percent of analyte in the precipitate, it should be the mass of analyte per mass of sample times 100. Okay, so see this example. Calculate the gravimetric factor of Cl2 in a sample is converted to chloride in precipitate is silver chloride. Calculate the gravimetric factor of Cl2 in a sample is converted to chloride in precipitate is silver chloride. So the relationship is Cl2 precipitate is silver chloride. So meaning that in order to make it balanced, we put 2 in front. So we can see 2 mole Cl2 related to 2 mole, sorry, this is 1, it's not 2. 1 mole of C2, Cl2 is 2 mole of silver chloride. Okay. So gravimetric factor is, we know gravimetric factor is the molecular weight of analyte over molecular weight precipitate times mole of analyte and then mole of PPT. So the molecular weight of analyte, in this case, the analyte we want to determine is Cl2 and its precipitate is silver chloride. So from the periodic table, we can calculate the molecular weight of Cl2 and also the molecular weight of silver chloride. So this mole of analyte and mole of PPT can be obtained from this relationship. Okay, so in order to calculate the gravimetric factor, the mole of the formula weight of analyte, which is Cl2, 35.5 times 2 over molecular weight of silver chloride. This one can be obtained from the periodic table. And then you multiply by mole of analyte. So mole of analyte is 1 and mole of silver chloride, which is 2. So when you calculate using calculator, you can obtain this gravimetric factor. All right, moving to another question. 1 gram of iron compound, after suitable treatment, it produces 0.1565 gram of iron oxide. So this one is Fe2O3. Okay, because this is iron trioxide, meaning that Fe 3 plus, oxygen 2 minus. Calculate the percentage of iron in the sample. It's asking about the percentage of iron in the sample. So the percentage should be gram of gram of analyte over gram of precipitate, 1.0 gram, this one, and then times by 100. So we know the iron compound treated to form the iron oxide. So you can write Fe converted into Fe2O3. So it needs 2 Fe to make it balanced. So we say 2 mole Fe related to 1 mole Fe2O3. So you can calculate the gravimetric factor, because from the gravimetric factor you can obtain the mass of analyte, because the mass of sample is already given. So gravimetric factor is, we know, gravimetric factor is the molecular weight of analyte over molecular weight of precipitate times mole analyte over mole precipitate. So you can use this chemical formula to calculate the gravimetric factor. So in this case, the molecular weight of analyte is Fe. So Fe can obtain from the periodic table, 58.85. And then the molecular weight of Fe2O3, which this one can calculate also from the periodic table. You can obtain the 159.7 times mole of analyte, which is 2, over mole of PPT, 1 over 1. So you can obtain the gravimetric factor. From the gravimetric factor, you know, mass analyte over mass precipitate. So you already have the gravimetric factor, which is this one, and then you know the mass of precipitate 1 gram, and then you can calculate the mass of analyte. So the mass of analyte, the gravimetric factor times by mass of precipitate. So 0. Sorry, not this one. This one is the mass of sample. The precipitate is iron oxide. So the gravimetric factor, which is this one, times mass of precipitate. The precipitate is iron oxide. So the mass of precipitate is 0.1565 gram. So you can use your calculator and then you can get the answer. So the mass of analyte, over mass of sample times 100. And then you can obtain the percentage of iron in the compound. I hope you can understand how to answer this question. All right. Moving forward to this another question. Calculate the percentage of bromide in a sample weighing 35 milligram that yield in dried precipitate is silver, EGBr, silver bromide, with mass of 187 milligram. So Br bromide is not bromine. Bromide is converted into silver Br. So the relationship is 1 mole Br related to 1 mole silver Br. So using the gravimetric factor, you can calculate the gravimetric factor as I show in this slide. You just follow, so you can calculate the gravimetric factor of this gravimetric method, and then from the gravimetric factor, you know the mass of analyte, mass of precipitate, so you can calculate the mass of Br. And then you can obtain the mass of Br, the percentage of Br. The mass of analyte, mass of sample times 100, you can obtain. Is basically similar like with this previous question. All right. Okay, so this is another exercise to calculate the gravimetric factor. I just pick one example, I think. For example, I can take this one for gravimetric factor for Fe. So it asking the analyte of Fe. So the gravimetric factor, we can calculate the Fe converted to Fe2O3. So we know 2 mole Fe, 1 mole Fe2O3. So gravimetric factor is the molecular weight of analyte Fe, I think 35.5, and then molecular weight of precipitate, Fe2O3. So 35.5 times 2 plus 16 oxygen times 3. So 119. So mole of analyte is 2, and then mole of precipitate is 1. So you can say 35.5 times 2 over 119. So you obtain oxygen is 16. 0.966, 0.59, 66. So this answer is slightly different. So you can check the double confirm the answer using the periodic table. Maybe I put a wrong number in this formula. So Fe to Fe2 is correct. Oxygen is, what is the mass of F2O3? 159. Why I calculated wrong? 35.5. 35.5 times 2 plus oxygen, is it 16? Yeah, 16 times 3. 8. If I replace it, 159.7. I don't know what's wrong with this one. You can double check. If I replace here 35.5, 159.7, and then times 2. So is it can get the same answers? 35.5 times 2 divided 1.917. Oh, it's wrong. Fluorine is not 35. Fluorine is 50, 58. 55.85 is fluorine, it's not chlorine. Yeah. Okay, it's wrong. This is iron. So iron is molecular weight of iron is 55.85. So iron oxide 159 times 1 times 2. Okay, let's see how. Times 2. Okay, 0.699. So it seems answer with this one. So you can try to calculate the gravimetric factor of this one, this one, this one, this one. So according to analyte given in this uh, table. Okay. All right. This is the last question, I think. This is the final year exams question. The iron ore was analyzed by dissolving 1.3 to 4 gram of sample in concentrated HCl. The resulting solution was diluted with water in the iron was precipitate SD in hydrous um, oxide. So this is the precipitate by the addition of ammonia. After filtration and washing, the residue was ignited at high temperature to give 0.5394 gram of pure Fe2O3. So this is the precipitate. So this one is the sample. So calculate the percentage of it asking you 3 or 4 in sample. The percentage, so you should know the mass of Fe3O4 over mass of sample times 100. So you have to calculate the mass of Fe3O4 from the precipitate of F2O3. Okay, so we have to calculate the GF. So in order to calculate the GF, gravimetric factor, we know F3, we know what? Fe3O4 converted into Fe2O3. So this one times 2, this one times 3. So yeah, so oxygen 8, oxygen 9. So this one, if we want to make it balance, half oxygen. So we know the relationship is 2 mole Fe3O4, 3 mole Fe2O3. Okay, yeah, same like this. 3 mole F2O3 and 2 mole F3O4. So we can calculate the mole of Fe2O3, and then also we can calculate the mole of F3O4. And then we can do mass and percentage. Okay, This one is using chemical factor. Okay, let's calculate by using gravimetric factor. Okay, we try. So gravimetric factor is the molecular weight of analyte, molecular weight of sample times mole of analyte and then mole of sample. Okay, let's calculate the molecular weight of Fe2O. Oh yeah, Fe2O3. We know F iron is 55 or 58, 55.85. We try this one. Oh, no need. Because it's already given in this answer, we can try and okay, we can try. So now I'm trying to calculate using gravimetric factor. So Fe, a molecular weight of Fe3O4 is this one, but you can calculate using your product table. So 231 84 molecular weight of Fe2O3 15969 times if a mole of F3 2 mole of F2, so 3 over 3 over 2 2 over 3 is 2 over 3. 231 231.84 times 2 divided 159.69 times 3. So what is the gravimetric factor? 0.9666. So gravimetric factor is 0.9666. So we can calculate them. We know gravimetric factor is the mass of analyte and then mass of precipitate. So we can calculate the mass of analyte, the gravimetric factor times mass of precipitate is 0.5394. 0.5394. Zero point 9666 times 0.5394, you can obtain 0.521 214 gram. of F3 of Fe3 or 4. Okay, so slightly different. So let's say we calculate the percentage. One point %46, 46.0 is slightly different, 5%. You can double check. So in this answer it given, find out the mole of a direct analysis. uh, Mole of Fe2O3. So the mass over the molecular mass, and then you can obtain the mole number. And then you know the relationship between Fe3O4, 3 mole, 2 mole, and then you can obtain the mole of Fe3O4. So the mole of 304 multiplied the molecular mass of 304, you can get the mass. Yeah, you can try, you can double confirm. You want to use direct calculation and also gravimetric factor. Okay, but the answers is slightly different. Okay, all right. Thank you very much. See you again on the next video on the last topic, which is topic 6. Thank you very much.